Thanks so much, Jing, and thanks for having me at this important event. Today, I want to talk about something that's perhaps a little bit less precisely on the topic of cryptocurrencies and distributed ledgers, but is, I think, adjacent to it or perhaps motivating to it, which is the topic I call social technology, and is inspired by this quote from Albert Einstein from 1932. So in the run-up to the 1933 Disarmament Convention, he wrote that what the inventive genius of mankind has bestowed upon us in the last 100 years could have made human life carefree and happy if the development of the organizing power of man had been able to keep pace with his technical achievements. As it is, the hardly bought achievements of the machine age in the hands of our generation are as a dangerous razor in the hands of a 3-year-old child. So what this quote, I think, invites us to do is to think about our political economic systems as technologies, and to insist that those social technologies try to keep pace with the advances in our physical. And if you think about, a typical technology, physical technology, it often advances by greater and greater fidelity to the world that it seeks to model. So if you think about communications technology, they start with writing, which is a very thin representation of the reality of in-person social life. And they progress towards things like the telegraph and the telephone and the television and the video conferencing, which are able to keep up more and more accurately, quickly, precisely with what it would be like to interact with someone in person. And I think that we need to aim for the same thing in the design of our political economic institutions, to move from sort of the thin representations of social life that money and individual identity and standard capitalist democratic institutions give to the reality of social life, to things that are richer representations of that. So I want to try to give an illustration of this, given that I can't really spell out everything in such a short talk. In particular, I want to talk about why current capitalist institutions we already know from just classical economic theory don't even come close to optimizing for the world in which we actually live. I then want to give an illustration of how we might come closer to that, but also how it falls far short of what we need even to solve those problems, and then illustrate some of the broader problems that are very much still open. Okay, so let me talk a little bit about what are standard capitalist economic institutions optimizing for. So if you read, the marginal revolutionaries, the classical treatments of economics, there's a huge emphasis on the notion of decreasing returns. This is, in computer science, you guys would call this submodularity. It's the notion that the more resources, the more people you put into something, the smaller is the incremental impact that they have on output or value or whatever you want to call it. Under these conditions of decreasing returns, capitalism can be shown to lead to efficiency. And the reason is that the basic notion of capitalism is that everyone is paid their marginal product, the incremental amount that they add. And under conditions of decreasing return, if you add up all the incremental contributions that everyone makes, that's less than the total production. That's the whole notion of decreasing returns, right? If the incremental contributions are less than the contributions of earlier units, then the sum of all the incremental contributions will be less than the total produced. And that allows the firm, the operator, to take the remaining portion as profit. So you can have profit maximization coincide with efficiency. And the classic example of this is a factory. The more people that you put into a factory, once you already have the physical plant there, eventually it becomes crowded. And so the marginal worker adds less than the total amount produced, and the factory can take the rest as profit. On the other hand, Under conditions of increasing returns, or what computer scientists would call supermodularity, the more units you put in, the more inputs you put in, the more productive every unit is. And under these conditions, if you add up the incremental contributions, they're actually greater than the total amount produced. And therefore, any profit will necessarily undermine efficiency. You can't have efficiency and profit at the same time, because paying everyone the efficient amount will actually lead to losses. Classic example of increasing returns is a city. We know that people cluster together in cities because they're able to produce more jointly than they're each able to produce separately if they were living in, shacks in the wilderness. And under conditions of increasing returns, we know that capitalism can lead to very bad outcomes. So software is a classic example of this. It's classically thought of as having zero marginal cost. And therefore, you either face a choice between a monopoly over it, which leads to prices that are elevated well above marginal cost, exclude people, control, dominate the network, or to things that are provided as sort of free and open software, which allows open access, open use, but provides no economic support for those who develop the software in the first place. So capitalist institutions either undermine the provision and or undermine the uptake of critical increasing returns infrastructure. Now, the problem is that if you think about almost everything that constitutes modernity, almost everything that capitalism claims is its great successes in creating prosperity, it comes from increasing returns. So cities are like at the core of capitalism. In fact, the term bourgeoisie, which characterizes the capitalist class, comes from the word Borg, which means city. So capitalism is tangled up in this notion of economies of scale from the very beginning. And of course, Adam Smith's pin factory was the classic example of where you can achieve more by putting more people together, dividing labor, etc. Another increasing returns phenomenon. Electricity, the third industrial revolution, was all about networks of connection and the way in which they can reduce the costs of producing electricity. And of course, the internet, the fourth industrial revolution technologies are all about network scale. And at the same time as all the sources of prosperity are from increasing returns, so too are all of the sort of fears and problems of the modern age, from global warming to the low quality of information that's provided, the inability of countries, especially capitalist democracies, to deal with disease suppression under COVID rather than just treating individuals, and the agglomeration of power that's happened within many of the leading digital platforms, which I think motivates much of the discussion here. All of these are examples of cases where increasing return tools in the context of capitalism fail to lead to good outcomes. In particular, the way I think about it is that capitalism is basically a decreasing returns machine, and prosperity is an increasing returns process. And you're trying to run an increasing returns process on a decreasing returns machine, and you constantly get compiler errors. And some of those compiler errors are the monopolies and the platform economy. Others are the low quality of information that we're getting out of current news environment, global warming, etc. So what I want to try to discuss is what would a something that's optimized for an increasing return setting look like. I'm going to start basically with a model where we just introduce one increasing returns process into a world that's otherwise decreasing returns. And that's going to lead to this idea of quadratic funding, which I wrote up with Vitalik Buterin, who created a THEOREM, and Zoe Hitzig, who's a PhD student at Harvard. And this can be shown, and I'll give a little argument in a minute, to be an optimal way of providing for increasing returns processes in a context of an otherwise decreasing returns economy. And the basic idea here is to change the funding formula from one that's based on just the linear aggregation of the contributions of the individuals to this quadratic formula, where the amount received by an organization is the square of the sum of the square roots that individuals contribute to it. So the basic idea here is actually very old, which is around matching funds. The funds that are received in a city like New York by candidates for public office follow a formula that's not too unrelated to this. In particular, individuals are allowed to make contributions to fund a particular candidate, but those contributions get matched by a public pool, but only for the small contributions and only if there's enough supporters of that candidate. So there have to be at least 1,000 supporters for the candidate for them to get matching funds. And then they get 6-for-1 match, but only up to $100 and none beyond that. Now you could ask, why $100? Why 6-for-1? These are arbitrary numbers, right? Quadratic funding gives an optimal formula based on this general principle, where small contributions are matched more than large contributions, and contributions to popular candidates are matched more than to unpopular candidates, etc. And this can naturally be used for funding all sorts of different things, from open source software to news and campaigns. Now, why is this formula optimal? Well, I won't run through the argument in detail, but if you're familiar with the idea of public goods, the basic notion is that people don't contribute enough because they only take into account their own benefit. And if they had a matching fund that sort of scaled it up as if they were acting for everyone else, as in Kant's categorical imperative, you act as if you believe that your action will be sort of imitated by everyone else, then people would contribute optimally. The problem is that, in a symmetric game where we're all the same, that's very simple. You would just match people n for 1. But in a game of heterogeneity where we're all different shares of the total, you really want to match someone for the inverse of the share of the total value that comes from them. And that's exactly what the square of the sum of the square roots does, because the square root, its derivative is the inverse, and the derivative of the square is just the sum of the whole. And so basically the marginal amount that gets contributed when you contribute $1 is the sum of the square roots over your square root. Okay, so this leads to some properties. First, when in this formula, a fixed contribution, if it grows as the square of the number of people that make that contribution. If you split the total value in half into 2 groups of equal people, that splits the whole funding that they in total receive in half. It scales linearly with money, but as we noted, more than linearly in the number of people. And it matches small contributions to popular causes the most. Now, a natural question is, where do you get the funds that support this matching? Well, there's actually a very elegant theorem by Henry George, or rather derived from the thinking of Henry George, by Stiglitz and William Vickery and others, that gives a natural way to do this. So everyone, at least in the United States, probably knows that areas that have good schools also tend to have high property prices, because people value being able to send their children to those schools. And in fact, there's this theorem called the Henry George theorem that says under certain conditions, the values of the property in an area rise precisely in aggregate by the amount of the value created by the school. So if the area were to own all of that land, it could extract that value and pay for any school that added positive value. Now, this only happens under particular circumstances, but more broadly, there's a result called the Henry George theorem, which says that that there are basically 2 types of activities in an economy. Decreasing returns activities, these will earn a profit, as we talked about earlier, under efficiency, and increasing returns activities that will take a loss. And you can always fund the increasing returns activities by extracting the profits earned by the decreasing returns activities. is basically related to the directed acyclic graph theorem. There's basically nodes in the system that are throwing off value, these increasing returns processes, and those will always be absorbed by some nodes that absorb value, these decreasing returns processes. And really, like, the fundamental principle of political economy is that you want to recycle the profits from the decreasing returns processes back to the increasing returns processes and kind of create a superconductor that leads the economy to take off. Now, the question is, can you do this without sort of killing the goose that lays the golden egg? In the process of extracting that value from the decreasing returns processes, do you slow down the whole thing? There's a brilliant insight by an economist named Arnold Harberger that there's a way to do this that actually accelerates things, that actually makes the market operate more efficiently. These ideas were actually originally pioneered. There's precedents to them in ancient Athens and in 17th century Denmark. And then Sun Yat-sen, the founder of the Chinese Nationalist Revolution, also implemented them, but they were really crystallized by Arnold Harberger in the 1960s. And he wrote, if you have to make a base for taxes, adopt criteria that determine the true economic value. The solution that the economist offers is simple and direct. Allow the owner to declare a value himself, make these values public, and oblige the owner to sell his property to anyone willing to pay the declared value. This system is simple and creates incentives even beyond those existing in the market for assets to be employed in their most productive economic use. And so the basic idea here is that with this system of sort of granting an option for someone to purchase based on your declared value, you actually create a self-enforcing tax system that can be recycled back to support these increasing returns processes. And if you imagine a world where most of the organizations, rather than being corporations or individuals or whatever, are these emergent public good entities, this is actually kind of a continuous form of election for this more dynamic form of democracy, because organizations will get some funding, but that funding will naturally decay, and then they can be sort of bought out when they're no longer the most democratically supported use. Now, these types of ideas are already having significant applications around the world, from Taiwan, where they're used extensively by the government's incredibly dynamic digital minister, Audrey Tong, to do participatory budgeting, democracy, et cetera. They're being used in the Ethereum community. Now millions of dollars every couple months are flowing through something called Gitcoin, which uses quadratic funding to support open source software. They're being used to budget in the state of Colorado, both in the legislature and in executive bodies. And we have a network of 100 local groups around the world that are working on implementing these with different governments and technical communities. And yet these ideas, I want to claim, are really just the beginning, because they're really not fulfilling even the full potential of dealing with increasing returns phenomena. Why is that? Because they're still based on the notion that these increasing returns processes are really like measure zero relative to a decreasing returns backdrop. They're basically based on this model in economics that's called quasi-linearity, where what people care about is the amount of money they have and the goods that they get. But that is only a reasonable approximation when almost everything is decreasing returns, when you have a capitalist backdrop and just a few of these increasing returns processes. But when increasing returns are pervasive, if most things are being organized according to these public goods processes that are generating these public goods communities, things are quite different. And I want to illustrate this not with these more sophisticated examples, but just with the simplest case of an auction for one item. Now, usually we think of in an auction for one item, a second price auction is efficient or something like this. You just want to put people on equal footing, have them bid, etc. But consider the following, I don't think, very atypical case of an auction. So imagine that there's a public auction for an artwork, and you have four important bidders. One is a public art charity in New York City. So it's going to be like the Metropolitan Museum of Art or something like that. Two are employees of a company that is down the street from the Met, and they're planning to display the work on their walls in their offices. And then one is a foreign country that thinks that this art was stolen from their people, 1,000 years ago or whatever. Treating these as if these are four symmetric unrelated individuals is absurd, because of course, if the individuals are going to put it in their walls on their, in their office, it hardly matters which of them gets it. And they're probably quite happy to walk down the street and see it at the Met, but they probably really don't want it going to the foreign country, right? So once you realize that most of the value that people have actually are public goods, shared value, treating people as if they're these isolated, symmetric individuals is preposterous. And this becomes even more severe once you try to deal with these public goods problems. So this is my wife, Alicia. If you imagine us participating in quadratic funding, do you want to treat us as two different individuals, each under a different square root, or one individual under the same square root? Well, it's kind of absurd to treat us as the same individual. We're two different people. But if you treat us as two different individuals, we literally have one bank account. And so we could just divide up that bank account, pour all our money into the two sides of quadratic funding, get that matched, and basically money pump out of the system costlessly, right? But I claim this is not just true for like a couple. This is true for all sorts of people. People are parts of a graph where they are closer or further from one another. They're not symmetrically distributed individuals. And so I think what we really need is to get beyond just quadratic funding or something like that with different isolated individuals each having their own square root, to the point where we actually sort of have people be linear or quadratic to the extent that they're close or far on a network. And there's different ways of thinking about that. But like one sort of rough conceptual framework is that there's actually kind of like eigenvectors in this network. And those eigenvectors are really what you wanted to be doing the quadratic thing over, not the individuals, because the individuals are not really independent influences. And I think that this offers quite a rich possibility, because we know from neural network theory that if you have like linear regressions of linear regressions, you get back linear things. In the same way, when you have like complex capitalist institutions all based on these linear pricing, you can get some richness, but basically everything is just capitalist markets. Whereas when you have these non-linearities created by these quadratic relationships, you can actually build all kinds of richness of a network economy out of that type of a relationship. And you can have, rather than money and individuals, you can have an evolving weighted graph that represents the state of the system. But even this is just like one instance of something that's left out of the usual capitalist logic. There's many other things, from the nature of communication and signaling to the ways in which people have to combine their thinking, not just linearly as in quadratic funding, but the kind of conversations we're having now, democratic governance of workplaces, and the different ways. And there's just endless things that we know from sociological theory are not included in the logic that capitalism optimizes for. And if we begin to build these things in and actually ask what approximately optimal systems are for them, I think there's really no end to the richness that we can get in reimagining our political economic institutions. And this happens all the time in other technologies. You think about artificial intelligence. It's not like people think, oh, there are just these little failures of artificial intelligence and we can just take our computers and fix a couple of externalities and they'll work perfectly. No, everyone knows that we're only at the start of our journey towards achieving something like the human mind. Or in communications, we know that we are our current communications technologies only are the start of getting us towards the richness of human experience. And we see sort of almost an infinite horizon of things we can achieve there. And I think we need to approach our political economic institutions like that. They're not this endless debate between capitalism and socialism, this endless, circular thing of Aristotle and Plato. They're actually, we have the possibility of making them ever richer, ever truer to the realities of what it is to interact with each other within a small community, but being able to do that in a diverse, large-scale society. And to make that a reality, we really need to treat political economy the way we treat technology. We need entrepreneurs experimenting with it. We need people imagining it in science fiction and game playing. We need scientists, economists, computer scientists to actually rigorously try to imagine radically different institutions that we can experiment with. And we need communities to play with these things the way that people played with the iPhone or played with virtual reality or played with early computing. to make them a part of people's lives so that change in the end comes from the bottom up, not from the top down. And I hope I can engage some of you in that process with the radical exchange community or otherwise. Thanks so much.
Thanks, Glenn. That's very interesting.
Yeah, very interesting. Can I maybe ask a question? Hi. So yeah, very fascinating work and important work. I have a question to you in the following sense. As you point out in your talk, maybe some of these ideas had at least some historical precursors, you know, like in different parts of the world, parts of history, and so on and so forth. So how do you interpret the fact that like maybe some of these ideas did not, you know, have not reached the, you know, maybe a critical mass so far? Like, do you think this is like, you know, maybe a historical accident, and somehow like, okay, now that, for example, that we have technologies like Ethereum and like mass communication, like we can really create like, you know, we can really coordinate ourselves better? Like, or do you think there are some other like fundamental issues that make these ideas in some sense evolutionary unstable? And just to point, to get some like an idea from one of your slides, like you had like a chessboard, you know, and then you know, I very much, you know, the chessboard, like the white and the black pieces, you know. And I think the way you've talked about the society, which I think a very idealistic, like and very nice pictures, like, you know, we're all together and somehow like maybe we're all for each other's good. But you look around and, you know, there's a lot of competition between companies, between different countries, or even unions of countries. So does your, you know, is this kind of like thinking of this type of like markets like stable in a world of you know, where not every game is a public goods game, but there's also like maybe a competition between different public systems?
Great questions. So, I mean, obviously these things are designed for the notion that people act selfishly, and that we want to try to overcome that selfish behavior. But so in that sense, that's taken into account in the theory. I actually think the biggest limitations of the theory, as I hinted at later, are less that and more the fact that they don't take into account the social, the positive social relations. I don't think they lean far enough into that, because the thing is that they actually, in many ways, overcorrect for people's selfishness. Like they create what standard economists would probably call collusion incentives. But I don't really even think of those as collusion incentives. They're just the fact that people are not atomized individuals. And therefore, you need to think about the way in which people socially relate to each other at the base of what you're trying to solve in the theory. And I think a fundamental problem in doing that has been, I mean, we take that into account in small numbers of people. But as societies have grown, you need network models to represent those things. Network models are very complex, right? And we now have tools that make it possible to process network things at very large scales. So those tools enable us to have that kind of network coordination at large scales. You know, when the origin of the nation state was with very limited technological capabilities, you had to ultra simplify the nature of social relations to allow for, you know, social intercourse at scale. But with network theory, that's not necessary. You can actually replicate much more of the way that social interactions work at a micro scale, at the macro scale, without such extreme simplifications, because you can sort of process and carry over all that information. Similarly, money was like the most reductive, forgetful, simplistic way to represent sort of some social value. But you don't need that if you're able to sort of store a weighted graph and do operations on it, right? So I think that the advances in our physical technologies have opened possibilities for our social technologies that didn't exist before. Even something like quadratic voting, which is relatively simple, really before the age of the digital computer would have been effectively, you know, impossible for people to keep track of. And even with digital computers, unless you have nice user interfaces that can adjust in real time, it's very hard for people to make sense of it.
Yes, very very interesting. And let me like add like one last question in terms of like the connections to blockchains. So like, do you think, do you believe that like from the perspective, let's say the blockchain tools we have, you know, what is needed somehow like to you know, in terms of technological assets and tools to move these ideas forward? Or like, do you think there's still some sort of like, you know, a critical kind of application that is out there right now, you know, for which you would have like some suggestions, say like, okay, if we had this, you know, this next piece of like, you know, decentralized software, like this would be an important stepping stone, you know.
So if you want to run the Radical Exchange 1.0 stuff, the stuff I talked about first, blockchains work relatively well, but you also need individual identity things. So you need like, you know, you need some way of knowing who's a separate person. You need some civil proofness. But ultimately, I don't think that blockchains are the right substrate for these. And the reason is that like at least a traditional blockchain architecture is built on the notion of a global open ledger with the connection of individuals to it secured by a private key. But the notions I'm talking about are really much more like the internet. They're about networks of networks. They're an n by n, you know, a distributed ledger is basically like an n by one by like, you know, n by some fixed number, you know, m or whatever architecture, because basically you expect every individual to have like, you know, some small number of entries in some global ledger. You see what I mean? Whereas a network is basically an n by n dimensional object, right? Where you expect to have an evolving set of peer-to-peer relationships. And there are, you know, blockchain derivatives like holochain and so forth that are more building on that kind of an idea. But ultimately, I think the original vision of the web is much closer to the idea. You want a bunch of different individuals with a bunch of relationships to other individuals, and you want that to be the evolving object, not some public, you know, ledger secured by private keys.
Cool. Thank you so much. Like very, very thought-provoking. Thank you.
Yeah, thanks, Glenn. That's really interesting. I want to add to some questions. You said that I agree, engineering the social institution is different from engineering technology where you can make a switch and get things going. What is your view on that? How to roll out this this plan in terms of scales and try out in small portions and so on?
Yeah, great question, Jake. So the way I think about it is, you know, there's a great book by Hannah Arendt on this called On Revolution, where she compares the French and American revolutions. And the point that she made is that the American Revolution happened basically by democracy establishing itself in local communities and becoming the default way of people organizing themselves, and then it becoming the formal system of government overall, only once it was already legitimated through the process of people using it in their lives. So it gained sort of power before it gained authority. Whereas, or it gained authority before it gained power. Like it became what people trusted before it was officially the thing, right? And the problem with the French Revolution is it went the opposite way. There was no tradition of local democracy, and they just sought to sort of decapitate the system and push down some new system. And that led to a lot of chaos. And so my belief is that what we need to do to make these systems work is, on the one hand, at the large scale, sort of restrain the power of the largest entities to prevent the development from below of new practices like these. But ultimately, it needs to grow up from below, from the sorts of communities using it and actually just performing better than other communities, and thereby displacing the systems around them.
So it's a bottom-up approach.
Yeah, I mean, paired with the top-down checking of the power to snuff that out, right? Because if you have centralized entities that are powerful enough to sort of stop the experimentation, then that experimentation can't occur. So you need both but the top-down process is a negative one. It's one of restraint. It's one of checks and balances. The bottom-up one is the one that actually grows the positive possibilities.
Thanks. That makes sense. Maybe I'll ask another short question, which is related to the network view that you mentioned. I agree that the network captures people's relationship with each other, but also to be realistic, networks are not easy to be analyzed and draw a clean conclusion over. Do you have any concrete plans about what type of networks may be easier to make progress? What type of networks are easier to capture?
So I am a huge fan of networks, as you saw, but at the same time, I'm actually a skeptic of network theory. And the reason is that I think that what we need to aim for is complex systems, not complicated systems. So I actually think that like what one wants to do is use simple insights to make interventions within complex systems rather than to understand or characterize or engineer complicated systems where you're actually changing the thing as a whole. Like you think about the internet, the theory that went into the internet to building TCP/IP was not some understanding of network theory. It was actually just an understanding of a switching protocol, which was at the micro level something that enabled the emergence of a broader complex system. So I actually think simple ideas that enable complexity are much more powerful than the understanding in total of the complex system in a complicated way. And that's what I'm trying to propose here, is actually like very simple ideas that people can grasp. The problem with network theory is it's very hard for anyone to understand it. And that makes it very hard for it to itself enable complexity. Because to enable complexity, you need the very simple elements that make up the system to be able to grasp the thing that enables the complexity to emerge. And what I try to engineer is things like quadratic voting, which I know it's a little complicated, but it's actually quite simple. Like you can basically convey to almost anyone with almost any level of education quadratic voting in like a 5 to 10 minute conversation. And that's like very, very different from network theory, where like you can spend like literally decades working on it and still have very limited understanding of anything that's going on. So I think we need to keep in mind that the world is a complex system, but actually engineer simple elements that allow that complexity to grow, rather than try to understand the complicated system and engineer it from the top down.